Hello, everyone. My name is Alberto Chierici. I'm one of the authors of this demo paper, a cloud-based user-centered time-of-set interaction application. And I had the honor and the pleasure to work with a fantastic group of people, including capstone students who work at this project as part of their capstones, and Professor Nizar Habash, Professor Goffredo Puccetti, and Erin Collins, who helped on the design side. The work was part of efforts at Camel Lab, and all of the authors are from New York University, Abu Dhabi. This is the fantastic team I just described, and I'm now ready to present you our demo paper. First of all, I want to define what time-of-set interaction applications are. These are interactive dialogue systems that simulate conversations with people who have previously recorded some videos, utterances, and an interrogator or interactor, we will call this user into these two different ways, will be able to interact with these videos like in a real-time conversation. These applications are interesting for preserving cross-generational and cross-cultural histories, but also for applications such as tutoring, coaching, interviewing, or other commercial applications we are seeing nowadays. Our work was inspired first and foremost by the New Dimension in Testimony project, a work by Traum et al. In 2015, where they built a Toya about Mr. Pinchas Gutter, a Holocaust survivor who could explain and record narratives of his political views, his experiences during the war and the Holocaust. And the Toya was exhibited at the museum in California for visitors to interact with this character. We've seen in recent years emerging some commercial applications. For instance, Video Ask by Tab4 is a way to, let's say, make surveys or interact with web visitors using video answers. And the same group that created the New Dimension in Testimony also worked at Storyfile, a system to build more applications like Mr. Pinchas Gutter Toya. The first work that was built in the Camel Lab at New York University, Abu Dhabi, was built by another group of capstone students, and they built a system, Abu Ali et al. 2019, they built a system with 4 avatars that could conversate in 2 languages. So interrogators could ask questions in English and Arabic and get answer from videos recorded in both languages. These applications was the starting point for our work, and the user experience wasn't really friendly, so we first redesigned the whole user journey. For instance, this is how an avatar maker would need to record videos. They would go through these screens, and after many clicks and many interactions with applications that were a bit clunky, they could finally land on a page where they could record videos. And the process of recording videos wasn't straightforward, because one of the problems we noticed was that asking people to just brainstorm video utterances to record would not provide enough coverage of questions and answers for interrogators then to have a good talkative experience afterward. So we let the user select some types of conversations, like here they could start an avatar from scratch or from a template or a narrative template. And when recording questions, it was quite clunky because they had to save every single question, and playing it back wasn't that straightforward. And as a result, they lost some of the questions they recorded. But also they didn't record obvious interactions like greetings, hello, goodbye, or affirmative statements, yes or no. So first of all, we redesigned completely using the help of professors and researchers in design, and we used principles of good design for the user interface, and we added the features that could help a more intelligent avatar creation process. And the architecture that I will briefly describe later is more modular, interconnected, and scalable. Regarding the design principles, we refer to the work of Nielsen in 1995, who suggested good design consists of these principles: visibility of system status, match between system and the real world, user control and freedom, consistency standards, preventing error, recognition rather than recall of user interface elements, flexibility and efficiency of use, good aesthetic, minimalistic design, and helping user to recognize, diagnose, and recover from errors. You can see here a few screenshots of the new designed applications. And if I can zoom in a couple of them, this is the screen welcoming a new user or toy maker, someone who wants to record videos. They can clearly see immediately messages that are relevant to them, such as how many people talked with their avatars, or we call them streams and I will define in a minute what a stream is. They could get a feedback on how many questions perhaps the dialog manager wasn't able to recognize or to play back, and therefore defining them as new questions that avatar makers could record for providing a richer experience. And they could immediately add a new video with a clear button or edit existing videos. Now, back to the definition of streams, we define also different, let's say, folders or folders or albums that represent the way avatar makers want or think interactors can speak with their avatar. For instance, a stream about my professional experience would be the folder of all answers related to my work. Or I could create another folder of videos answering questions regarding, let's say, me as a person or my hobbies or things I like to do. And I would probably call that as a personal stream. Here we have a snapshot of the recorded, redesigned. We give a lot of guidance and smart suggestions to the user. The user can clearly see buttons for recording a new video, pausing, or playing back. When the video is complete, we have automatic transcriptions that plays back what sentence was recorded, and the user could also edit it in the case that the ASR didn't work really well. The user could also flag what type of question or video utterance they're recording. It could be a simple Q&A utterance or yes/no answers, greetings like hello or goodbye. They could toggle the video to be public or private, so they can have they can decide which answers or video utterances could be accessible or not, and define streams. So define folders where these videos are sitting, and interrogators could later interact with avatars on a certain stream. Regarding the architecture, this is a very high-level picture comprising how we built the system, and we have a web server deployed on Google Cloud that consists of all the backend and the user interface elements, and we plugged in a modular way two microservices. One is the question generator, and one is the dialog manager that I will describe in a second. And it's important to keep these as microservices because in this case, researchers could build separately these components or experiment separately on these components and say upgrade them, upload them once they're ready. At a deeper level, this gives you an overview of how the architecture looks like. And you will also see this if you go on our webpage and access the GitHub documentation. So I'm not spending too long on this. And just one component worth mentioning is the question suggester, which is a component that was inspired by how much we are used from other applications to receive suggestions like Gmail auto-completing a sentence or suggestions on Google Maps or LinkedIn, suggesting people we might know. We noticed that avatar makers, when they were creating avatars, they were struggling because they were just brainstorming out of the blue interactions or video utterances to record. And we want to suggest them what type of question and answers they could record to provide a smoother experience, and also to avoid like creative blocks or blank mind. The process would work like that. We ran a proof of concept already, thanks to the work of one of the capstone students that I mentored, Kertu Koss. And the avatar maker would start creating questions by typing in or recording question and answer. And we would use generative models such as GPT-2 to use that as an input prompt and generate streams of dialogues from that, and use other models to validate the proposed next question by the system. And this would provide to the user question suggestions to select from and create avatars in a more streamlined way, and help the avatar maker to brainstorm questions faster. We invite you to try our applications. We're going to share the link, and you'll be able to access the application and download the source code, try it yourself. And this would be used by researchers, and we plan to make the datasets we create available. We plan to make everything open source and available for researchers who are interested not only in Toya, but generically in dialogue systems, to create corpora that are interesting and leverage this type of innovative and original interaction. This is the link, toya.camel-lab.com, where you're going to find the live application. You can create an account and start recording your Toyas or interact with the existing ones. If you head over the About Me page, you will see the GitHub repo where you find the source code, our contacts, and publications. Thank you, and I hope to chat with you soon.